I'm Ethan Kwan, and today I'm going to be showing you different atom thingies. So, I'm just going to download a photo of the periodic table here. Okay, there we go. Okay, so this is the periodic table, as you know, and I am going to measure the atomic radius of maybe hydrogen. This guy right there. So this might seem easy to you because, let me just switch. Okay, so hydrogen, actually let's take something else like sodium or something like that. So sodium, let's take potassium, this guy right there. We can't see potassium, sorry. So potassium has 19 dots, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 in the nucleus. And these are protons. And now, of course, there are the electrons. The electrons buzzing around. And you might picture it like this, where... Very incorrect. Actually, it's a cloud of... It's a cloud of... I'm not even keeping track anymore. Okay, let's say that's the... Too dark. Damn. Okay. Okay, so instead of that kind of thing, you have this part of probable electron locations like this. So usually there might be electrons more common in this area. Usually electrons are in this area. But electrons are unpredictable, so there might be some chance of it being here, but not as much as there. And there might be some chance here, but not as much as inside that probable electron location. And maybe there's a chance out here, but there isn't very much of a chance that it would actually be here. Okay, so how do we measure the radius of an atom if maybe, so you might think it's just the outermost electron, but it could be like right here, which is where the radius would be here, or it could be out here. Very rare, but still, and the radius could be here. So, how do we actually measure? This is the hard part. You know what? I'm just gonna... put that over there. Okay, so, let's say we have two atoms, and they're this close. And this is how close they can actually get before bumping into each other. Now, what we do is we look at the distance between these 2 points, like this, and take the half point, and that would be the radius, and of course this would be also the radius. By the way, these two are exactly the same atoms. Anyway, and this is how close they can get before bonding with each other. But let's say they do bond. Aww. Anyway, that one. There we go. What if they do bond? Aww, cute. So basically, instead of an atom having just its electrons to itself, it can actually share with others. So this electron could be going around like this, and then might be in here, and then go back out there, and then it might go into this one. No. Okay, that's better. Okay. Okay, so now we take the distance between between this center and this center, and we take the half of that, and that could also be the radius. Simple. Okay. So I want to talk about. Now I want to talk about atom size. How big are atoms? So I'm just gonna kind of delete all this because there's not enough space. Keep going. Almost there. Yay. Okay, almost there. I don't want to get rid of the periodic table, so there we go. Okay. Oh, no, I have to get rid of that stuff too. There we go. Okay. So, so let's take the fourth row as an example. What do you think the trend will be of its size as you go from left to right? Just like you're reading a book. I want you to pause the video. Pause. And think about it for a little. Okay, so what's the difference between potassium right here and krypton right over here? Well, the difference is that they're going to be different sizes. But which way? Is this one smaller than this, or is it bigger than this? Well, so potassium is like this, right, with electron shell probable things. Let's just go back to shells for a minute. So potassium has maybe 18 electrons closest to it, and then maybe a 19th electron out here, and it's out here, and this one's the loosest one. So this will be as far out as it wants to. But for krypton, this is the positive charge, the nucleus, and so there are 36 electrons around it. So 35 of them are right here, and then it has a full shell outside. But these are going to be drawn to the center more than this guy because the positive charge isn't as strong. So that means the radius of the entire atom, like this, will go down. So that means that as you go further from left to right, the atoms are going to get smaller, not bigger, which is kind of weird, but bear with me. Anyway, so what about up and down? So hydrogen. So what about this row here? So so as you see, so it's gonna. So here's the nucleus of, say, rubidium. This one, and it's gonna have a lot of electrons in here, but one really far out. And so the electron's gonna be really big. But then if you take francium, 87, that's also gonna be really big, but bigger. Because, well, it's gonna be like out here. And it's going to be like this big. Sort of. So, as you can see, as you go down in the rows, it gets bigger. So, this way is small, and this way is big. Interesting, right? So, what will be the smallest atom? Well, if you go, so if you go up, it's going to get small. And if you go that way, it's going to be small. So what's the highest element with the highest of this way? It's going to be a noble gas. One of these guys. But which one? The top one. So helium is actually the smallest element on the periodic table. Now, the biggest elements would be right here. These are going to be the biggest elements. Interesting, right? Okay, I want to also talk about metals now.